In this lesson, we're going to be looking at the Pythagorean Theorem. Our objectives: understand what Pythagorean Theorem is, understand how to use the Pythagorean Theorem. Our vocabulary: right triangle, triangle with a 90-degree angle. Leg, one of the two sides that create the 90-degree angle in a right triangle. Hypotenuse, side opposite the 90-degree angle of a right triangle. Pythagorean Theorem, formula used to find length of sides in right triangles using squares made from side lengths. Basically, we're going to find a pattern to how the side lengths of a right triangle work together. So what I have here is a triangle in the middle, and on each side I have the measurement of the side, and these are actual measurements. This is 6 inches, 8 inches, 10 inches. What we can do is we want to find the area of each square that I have created off of the sides. So let's start with the smallest square here, 6 inches. So the area of a square is s squared. So 6 squared would give us 36 square inches. So A here is 36. Okay, then let's go on to this one. 8 squared would be 64 square inches. So this A is 64. And our last one, 10 squared, would be 100 square inches. So that's 100. Now, if we look closely, 36 and 64 added together equals 100. So squaring the two legs and adding them will give you the square of the hypotenuse. This right here is the hypotenuse. Here's our right angle. There's the side opposite. So this is our hypotenuse. And these are our legs. So if we square our legs and we square our hypotenuse, the legs should add up to the hypotenuse in that situation. So what we need is a formula to kind of put this together. So what we typically do is we call leg 1 A. So what we can do is we can go A squared, because that would give us the area of the square on leg A. Leg 2 we typically call B, so that would be B squared. What we said we want to do with these two areas is add them together, and they should equal the hypotenuse, which for the hypotenuse, we typically call it C. So this is C squared. Now we have a formula that if we know two of these, we can figure out the third. So here are two examples. In this first one, I'm missing the hypotenuse, which is a little bit quicker method to doing this. What we know is if we go, here's a leg and here's a leg, so A squared plus B squared equals C squared. So I'm going to substitute everything I know. So 2 goes in for A, 2 squared. 4 goes in for B, 4 squared. Those are on the sides of the right angle. And that should equal X goes in for C, so X squared. Then we just do some math. So we've got 4 plus 16 equals X squared. 20 equals X squared. Well, then the question is, how do we figure out X? Because we don't want to know X squared, we want to know X. So we just square root both sides. So X is the square root of 20, and if we want, we can use a calculator to estimate that. So square root 20, about 4.5. Okay, now let's do it with a leg missing instead of the hypotenuse. So again, we start with a squared plus b squared equals c squared. A, we're going to use 5. So 5 squared plus y for b, y squared, equals c of 13 squared. Okay, do the math that we can. 25 plus y squared equals 169. We want to get y by itself, so this is either a balance or box problem. We're going to subtract 25. Y squared equals 144. And again, square root both sides. And calculator can come in handy here. Square root 144. And we know that this side is exactly 12. Alright, this has been the Pythagorean Theorem. If there's any part of this video that you didn't understand or you need to see again, make sure you pause, rewind, and rewatch, and bring any of your questions to class. Thank you.